So this question here, we've got the order of the numerator and the denominator are the same, so we can't just split it into two partial fractions like this. We've got an extra complication. So the way I would do it, and I think the way we did it before, is to divide it out. So I'm going to do a polynomial long division. Now you might be thinking, oh, I hate that technique. Well, if you're in that position, you need to definitely come along tomorrow after school, because we're looking at the factor theorem and factorising cubics. So I've sent you some questions earlier in the week. Basically, if you look at those questions, you think, yeah, I can do that. Don't need to come. But if you can't do that, you need to come. And if you want to come just for kicks, that's fine. So I'm going to divide it out. It's this divided by this. But remember, I haven't got an x term, so I need a dummy x value in there. And the same is true of what I'm dividing by. And it's really quick and easy, because your first question is, what do I need to do to that to turn it into that? Multiply it by 1. So we do 1 times 9x squared, 1 times no x's, and 1 times minus 4. We then work out our remainder by subtracting. 4 minus minus 4 is 8. Now there's nothing left to bring down, so we're finished. We're finished. So what that tells us is that this sum is equal to 1 plus 8 over that. So I know that A is 1. So one option is then to do partial fractions for this. Remembering that that's, better get it the right way around, 3x minus 2, 3x plus 2. So just want to partial fraction that bit. I mustn't forget that 1, but I'm just partial fractioning this up, having realised that that A is going to be 1. So you're asking, what have I not got here that I've got here? That's what you need to multiply by. What have I not got here that I've got here? Not very nice, but if you use your calculator, so you set 3 over 2 as your x value and just type in 3x plus 2, 3x minus 2, it's a lot easier, or you can do it in your head. Super duper. Yes.
Yeah, it's not 2 over 3.
Sorry. Thank you. Thank you. So it's going to give me. Oh, of course I've confused myself, haven't I, by using A and B rather than B and C. Are we okay with that? So that should be my B over there, shouldn't it? It's the numerator for x minus 2, so that's 2. And that should be my C, which is minus 2. I got that the right way round? Yeah. So I'm in a position where I could now integrate. So let's just rewind for a minute and say that the division thing throws us off completely. Do we have to use the division thing? No, you don't. You can use partial fractions straight away by asking, what's that not got in its denominator? Well, it's got no denominator. It's a over 1. So you could... And then this is missing the 3x plus 2, and this is missing the 3x minus 2. So you could do it straight away like that. As with all 3 variable problems, having substituted in your 2/3 and your minus 2/3, you need another value. And so you might fancy having a go at that way in your own time. I haven't got time to do it now, but that's an alternative approach. And particularly for those who find that is a bit tricky, you might find that that's a better way of doing it. I don't know. I'm going to leave you to decide. Anyway, whichever way you get there, we should get to here. And we now want to integrate this. We're being told to integrate this. So let's integrate it. That's going to be just x. These two are going to be log terms, and I know that the 2 is going to pass through unchanged. And we're asked to substitute in minus 1/3 and plus 1/3. So go on, see if you can finish that one off. The other one like this is question 7, which is the one I'm going to ask you to have a go on your own. If you've already done 5 and got an answer, then you might have a start on 7. But so we could have got to this point using 2 methods. We've done it one way. You might want to try the other way independently. But now I'm asking you to integrate that, remembering that the second 2 terms will be logs. The ln of the denominator divided by what you get when you differentiate the denominator. Means if it's negative, you just take the positive value, the modulus. So if you're ahead of me, question 7 is the one I'm going to ask you to do independently. Let's start. So the modulus means I don't have to do with any negatives. So although x is a third makes that equal to -1, I just use ln of 1. And that's great news, isn't it? Because ln of 1 is 0. So that term's going to disappear. And over here, when x is minus a third, so that's -1 plus 2, which is ln of 1, and that's 0 as well. So that term disappears.
Yes, he is.
I think I've got the rest of it right. So 3.
Just waiting.
Yeah. Right. So what have we got all together? Are you looking? Have I made another mistake, Charlie?
No,
No,
I'm confused.
Oh right. Where have I lost you?
I don't know. I did it. I didn't know what I've done.
So 3 lots of a third is 1. Take away 2 is -1. But it's the modulus sign, so we just do ln of 1. 3 lots of a third is 1, plus 2 is 3, so that's where that ln 3 comes from. So if we look at what we've got, I've got a third plus a third, so that's 2/3. I've then got minus, and look what I'm going to do here. 2/3 the log of 3. Minus. Yeah. So how many lots of the log of 3 have I got? I've taken away 2/3 of it, and then taken away another 2/3 of it, and there's a plus c at the end. And then how does it want the answer given? It says it wants it in the form A plus B ln c, where A, B and C. So no, we don't need the plus c, do we? Because we've factored. So we're okay. A plus B ln c. Just got to double check I've done that. I did this with the other group the other day. I think that's what we got. Yes. Okay. So question 7 is another example of one where you've got a numerator and denominator with the same order. They've already factorised the denominator. So you've either got the option of doing the division, which would require you to multiply the denominator out, so work out what you've got here, or doing it straight off as partial fractions. But please make sure you have a go at that, and I can very happily go through that with you on Wednesday. After school if you want to come along with that, or Thursday. This Thursday, by the way, I'm in the Key Stage 3 detention room, so it'd be great if we outnumbered the naughty boys and girls. Please come along, don't be shy. While we're talking about sort of extra stuff going on, so I am confident that we're going to finish pure by the end of term. I did think we'd finish integration and do some more mechanics, but no, I think we're going to finish pure. That leaves you with a little bit of mechanics and a little bit of statistics. I'm going to do the mechanics by video, which I'll do during Easter. I hope you'll choose to consume them during Easter as well. We'll do the little bit of statistics, week and a bit, maybe 6 lessons after Easter, and then we're full on into revision. Hopefully you're getting into revision now. I'm hoping you're getting into those past papers, because they're tricky. I want you to start exposing yourself to them so you can really start to make progress. Easter holidays, absolutely crucial. All right, if you've got a 2-week beach holiday planned for Easter holidays, cancel it. All right, don't do triple shifts in your job over Easter. You can't afford it. All right, that's when you're going to go from being, someone who has learnt the content to someone who's going to be an exam ninja. That Easter 2 weeks is absolutely crucial. And so, as well as me doing the mechanics videos, I'll try and organise a couple of occasions when people can come in if they want, and we can troubleshoot exam questions that you've done. But I'm going to give you extra papers for that Easter period. So don't worry about getting through those 6 papers between now and Easter. Let's absolutely go for this. We can't afford it. When I was revising for my A-levels, I went to stay with my grandparents in Eastbourne. Now Eastbourne is where people go to die and then forget why they went. And it was in 1988, so there was no internet. They hadn't got a television even. I had a copy of Bon Jovi, Slippery When Wet on my Walkman. That was the only entertainment I had. And I locked myself away in a room and spent my week revising and eating my nan's chocolate cake, and it was that's the way I do it. It was like a Rocky IV movie, where he goes and isolates himself. You've got to do it, and if I know lots of you work, and that's absolutely brilliant. But if you've got an employer who is saying, "Oh, I really need you to do this shift, this shift, this shift," I'm very happy to phone them and say, "Look, can we find a balance here?" Because it's so important, and I know the holiday season is ramping up. But I could almost say that that grade battle could be won and lost in that period. So please take that period seriously, and then we'll do more past papers in lessons after that. Okay. Right. Let's move on. we are now at the daddy of integration techniques, numero uno technico, as my Spanish colleagues would say, I'm sure. Yeah, this technique is called integration by substitution, and it may be something that you've heard people talk about or you've seen. Certainly if you've looked at paper 1 in the brown envelope pack, question 14, which is a question I've said you can't do at the moment, is an integration by substitution question. So certainly by the end of tomorrow's lesson, you can scratch that one off and have a go at that question. That's another one you can do. Yeah, I've spoken to it. So we're not going to do... it might be tempting to look at that and think, that's an integration by parts question. And yeah, we could certainly do it using integration by parts, but we'd get into difficulties. It'd be one where we'd eventually get stuck. And certainly there's no other technique that we've covered which would come anywhere near allowing us to do this. So this is where we need a new technique. And it's quite an elegant technique because all we do is we replace x with u. And we replace it everywhere, including, and this is very important here, this dx is not something we normally pay attention to. I know I regularly forget to write it. But this is the little statement that says x is our variable. X is the thing that I'm going to increase the power by and divide by the new power and blah, blah, blah. Other letters are just constants. And we need to change that, so we're now dealing in terms of u. So here's how we do it. So here's the question, and generally these questions are in two types. They are ones where they say use this substitution, or they say use a suitable substitution. So you have to work out what the substitution is. I'm hoping you can see how replacing the thing under the square root sign with u makes this question a little bit easier. See, look, I've already forgotten to write the dx. So this is my little separate area where I'm going to do a little bit of sort of dirty work that will allow me to solve this problem in a more elegant way. So the first thing I'm going to do is differentiate this expression. It's u equals something to do with x, so that's going to give me du by dx. And if you differentiate that, you just get 2. And the reason I'm doing this is I need to get rid of that dx because I'm no longer going to have an expression in terms of x, it's going to be in terms of u. So I want an expression here that says dx equals something to do with du. And here's what I can do. Just multiply by dx, divide by. And I want you to, when you see something like that, to think, right, that is a half of du, a half multiplied by du. And what we can do is pull that half back into the rest of the expression. So, different colour required here. So I'm going to replace dx with a half of du. So I've done, and I'm going to always do that bit first. The bit under the square root sign, well, we're saying that's now equal to u, so that's going to be the square root of u. And in a minute I'm going to rewrite that as u to the half. You may already choose to do that straight away. Got to replace this x here. Now it's okay, I can do that because I can quite easily take this expression and write it as and I could have written it as half of u minus 5 over 2, but because of what I'm about to do, you'll see why I've left it like that. So this half I'm going to pull into the rest of the expression, and I note that if I look at what coefficients I've got a half times a half, which is a quarter. And we know what happens to coefficients. Try not to think of peanuts and sweet corn, but we know what happens to them. So I'm going to write that outside my sign, okay? It's just going to make it fiddly if I leave it in there, so I'm going to write it outside. I'm also at the same time going to write the square root of u as u to the power of a half. Now this is still a bit of a mess. I still can't integrate it, but if I multiply out the brackets, I get u to the power of 1 times u to the half. Add the powers, u to the power of 1.5. And I get minus 5 times u to the power of a half. Now, I can integrate that. It's two separate terms. With both of them, I can just increase the power, divide by the new power. So go on, do that bit for me. Don't forget you've got a quarter out the front. And you'll probably be able to simplify each term, because you'll have a fraction in the denominator that hopefully you can deal with. So we get u to the power of 5 over 2 divided by 5 over 2, which is the same as multiplying by 2/5. And you could write that as 2/5 times or 2 over 5. And minus 5 divided by 3 over 2, which is the same as 2 over 3. With the quarter out the front. And the final step is to say, actually, this question wasn't about u, was it? It was all about x. So I'm going to just replace u with 2x plus 5, which never looks pretty, but there we go.
Does it matter if you times by the quarter?
No. You can leave it out there, or you can, if you times by the quarter, your denominators will just become 20 and 12. But or you can just leave it out there. So we've taken something we couldn't integrate, turned it into something we could integrate using that substitution approach, and it was. It's a really neat trick. And these questions are often horrible looking, and then all of a sudden they stop being horrible. And certainly the question 14 on the first paper, I did this morning period too, and it's horrible looking. It is really scary. But you do it, and all of a sudden it suddenly becomes not horrible. And if it's not becoming not horrible, it probably means you're doing it wrong. So anyway, we'll worry about that one later. Can I give you a different sort of question then? So, looks a little bit like one of those ones that become logs. The thing on the top is what you get when you differentiate thing on the bottom, but oh no, that doesn't work. That doesn't work, does it? And certainly none of the other techniques we've got so far work. If only it was two things divided by one thing, I can split it up into two separate fractions. But it's not. It's one thing over two things, which I can't split up, and I can't use partial fractions because it's not a product of factors. Anyone like to suggest what substitution I could use that would reverse that? I want u to be equal to something like here. This was causing me problems, so I made u equal to that.
Would you make u equal to x plus 1?
Let's try. Let's try. Let's add a punt at that. Well, let's differentiate it, because we always replace the dx first. Oh, that's nice and easy. So I can just replace dx with du in this one. No, nothing else. Nothing else. And my denominator is just going to be u. It's suddenly become one thing. Ah, optimistic. George, what's x going to be then if we're using this substitution? How can I rewrite that so it says u minus 1? Ah! Heterogeneous, because all of a sudden it's become two things over one thing. I can split that up. I'm allowed to do that. I've got u divided by u. That's just going to become u, not x, because remember u is our variable, and this is going to become the log of u. So just see if you can finish that one off. Don't forget the final step of replacing the u with x plus 1. And generally, when it says choose a suitable substitution, the substitution is generally the thing that's causing the problem. So in this case, it was the thing under the square root sign. Here it was the denominator. So you know that's generally it's fairly obvious. But of course, you know sometimes you just have to have a punt. Now I don't know if you're thinking, oh dear, this is complicated enough. Thank goodness we haven't had any trigonometry to deal with. Well, I'm afraid I have bad news. Very often we find these questions involve trigonometry. So let's look at a trig example. Now, do you remember what I said about how these look horrible, and then all of a sudden they don't look horrible? Well, Exhibit A, this definitely looks horrible, doesn't it? See if you can get as far as replacing the dx. So I've replaced dx with du, but annoyingly, I haven't got rid of x's because my expression for what du is has got a cos x in it. I hope there's a way of getting rid of that cos x, otherwise I'm in trouble. Come to that in a minute. This is u, so that's u cubed. Sine x is u minus 1. Cos x is a problem, and I can write cos x in terms of sine. I've got a square root though, and then I've got the whole plus or minus thing. I'll just leave that there for now. Oh, hang on a minute, look. Remember, this is effectively being pulled back into the rest of the sum. We're dividing by cos x. If I'm multiplying by cos x and dividing by cos x, not a cos x in sight. So all of a sudden, something which looked fairly horrible has been reduced to u times u cubed, u to the power of 4, minus 1 times something which isn't too bad at all. So something which looks horrible all of a sudden becomes something which is not quite so horrible. See if you can finish that one off. Don't forget the final replacement at the end. So I wonder if at this point it's worth. Oh, still it's not at this point. No. I'll tell you what. Let's very quickly just try see if we can do one. We can just have a look at C. Have a look at C from question 1 here. Replace the dx first. So you're just having a go at C from question 1. See if we can get this knocked off in the 5 minutes we've got left. Must be 313. I've got that same problem as I had before, in that I've got this something to do with x as part of that substitution. It'd be really nice if I had a sine x up top that I could cancel it out with. Well, actually, look, I've got 3 of them. So if I rewrite this as sine x times sine squared x, they cancel out. I've still got the minus that I need to draw back in. So I end up with this. Now, sine squared is 1 minus cos squared. So that's or so sine squared is 1 minus cos squared, so that's 1 minus u squared. It's minus sine squared because that minus down there didn't get cancelled out, so that's still got to be drawn in. I could have drawn it outside the brackets, I suppose. So when I integrate, and I'm sorry this was rushed as is often the case, you get minus u plus u cubed over 3 plus c, or minus cos x plus cos cubed x over 3 plus c. So just help me out to speed things along. You've got the page 313, question 7. I think it must be 313, not 312, but it's the end of that partial fractions exercise. Then just have a go at this one ahead of tomorrow. So we're revved up and raring to go.